In the prior video, we talked about creating a project in Unity. Now let's talk settings. The Unity player settings is where you'll configure various parameters for your Unity application. Be aware that different platforms will contain different settings. The Android platform, for instance, will have notably different settings than PC, Mac, and Linux standalone platform. At the bottom of the player settings are the XR settings, where we can enable virtual reality. Let's go ahead and do that by going to Edit, Project Settings, and it'll automatically jump us into Player. Here are our XR settings, so let's tick Virtual Reality Supported. Enabling VR in a Unity project is easy, but creating an application specifically for VR is notably more challenging. After checking the Virtual Reality Supported checkbox, a list of Virtual Reality SDKs will appear. Some may be added by default depending on your platform and what package you may have already downloaded. In our case, we see that Oculus is automatically added. Clicking the plus button at the bottom of the list will give you options to add any additional associated SDKs that you might want. Let's take a look at some of the other options in the XR settings. Let's start with Mock HMD. This can be used with both multiple and single pass rendering paths, and it will render as a split stereo display in the editor. None will be treated as no VR device, and is used for creating a non-VR app that may launch into a VR application at some point. Oculus, grayed out here as it's currently active in our project, enables the use of the Oculus Rift and Oculus Rift S on PC, Mac, and Linux standalone, and Oculus Go and Oculus Quest on the Android platform. OpenVR enables the HTC Vive and other HTC VR headsets, and note that it's also been enabled by default. Stereo Display, or non-head mounted, enables stereo rendering for non-head mounted platforms for 3D displays. Now let's take a closer look at the Oculus SDK options. Notice that there are additional parameters nested underneath the Oculus listing. The first is Shared Depth Buffer. Any OVR overlay layer will render in the scene at a defined depth. If any of the objects in the scene are closer, they may render on top of the OVR overlay layer. You could choose to ignore the shared depth buffer in certain situations, like a loading screen or a pause overlay, and have your OVR overlay layer always render on top of the scene. Keep in mind that this sort of direct manipulation of the Z buffer can feel awkward to the player, since it doesn't really make physical sense based on perceived distance. The other option is Dash Support. If your application supports Dash, when it pauses, the Dash menu will be drawn over your paused application. If your application doesn't support Dash, it will be paused by the runtime and the user will be presented with the Dash menu UI in an empty room, similar to the way that the universal menu was previously displayed. When the Dash UI is active, the runtime will render tracked controllers in the scene to interact with the menu. For more info, check the developer documentation at developer.oculus.com. Dash support is recommended and can integrate your game more fully into the Oculus ecosystem. We'll include these resources for you at the end of the unit. For this unit, we're going to be disabling both shared depth buffer and Dash support. We'll revisit them again in later units. Check out the next video where we'll be setting up our own scene to create a vertical slice of a virtual reality escape room.